Sometimes in business it can seem like the development team and management are in two completely different worlds. Management needs a new feature out by the end of the month, but the developers are talking about refactoring code. But if the code works, why do developers want to refactor it? Does the structure and organization of the code really deserve large allocations of time under pressing deadlines? What's going on, YouTube? This is Nick back again with another video demystifying technology for the technical and non-technical people alike. I'm a current tech lead, senior developer, and consultant with more than half a decade working in the web dev space at a multitude of consulting firms for a multitude of high-profile clients. And today, for free, I'm going to answer the question, if the code works, why are we changing it? We'll start with getting an intuition for what high-quality code is and why it's important. Then we'll discuss how to approach thinking about refactors. If you're a manager and you don't have a ton of technical experience, it may be hard to wrap your head around healthy software or high-quality code as a concept. To the non-technical person, healthy software means bug-free software delivered on time that meets the needs of the clients or users. But to a developer, healthy software has much more to do with the quality of the code itself. The fact is, code that works, is on time, and meets client needs isn't always high quality code. But what is high quality code? There's no point in getting into the weeds of all the varying opinions surrounding what constitutes good coding practice, and that's not the point of this video. I want to give you all a high-level intuitive understanding of good practice without having to dive too far into any technicalities. But before we start, we need to address the reality of production software. The truth is, developers have different priorities than the business at large. When a project misses its deadline, the employees in the crossfire tend to be managers and not developers. At the end of the day, managers make the hires, give the estimates, and take responsibility for the well-being of the team and the project. And therefore, managers fear deadlines. Developers, on the other hand, tend to care more about the health of the project generally. Developers are the ones who have to work on the project daily, so if the project is not in good health, they're the ones who are going to have to struggle with it, not managers. It's important that we recognize this misalignment of priorities because it can help us understand why managers and developers make the decisions they do. Let's think of these as our biases. Managers tend to be biased towards meeting deadlines, and developers tend to be biased towards healthy software. All this to say, there's certainly room for the healthy skepticism that managers tend to have for refactors. Sometimes developers initiate refactors for bad reasons, sometimes refactoring can be dangerous or counterproductive, and sometimes an over-focus on code quality can slow down the project. It's completely fair to say that your end clients do not care in the slightest about the quality of your code. If your code does what it's supposed to do, then they're happy. But without that intuitive understanding of what high-quality code is and why developers find it so important, it's impossible for a manager to make educated decisions on when refactors need to be prioritized and when code quality can be temporarily overlooked. Okay, so back to the point. What is good code quality and what does it win you? Developers look at code bases in a completely different way than the majority of managers. When a developer looks at a code base, rarely do they focus much on the actual end product. They're looking at the organization of the repo, they're looking at the readability of the code, and they're using a combination of their industry knowledge and coding education to look for potential red flags. Developers work in the code base like a chef works in the kitchen. You could imagine how hard it would be for a good chef to cook if the kitchen was dirty, unorganized, and things the chef expected to work a certain way did not. Any good developer, like any good chef, is gonna want a clean kitchen. That's not to say that a messy chef can't make great food. That's to say that you would expect that a chef who cooks great food would not tolerate a mess in the kitchen. Which is to say that one of the biggest wins of high quality code is developer satisfaction. And I'm talking about this win first because I believe its importance is understated. You will not keep a good developer working at your company if the code base is painful to work on. I've worked in code bases that were a complete mess, and it's a telltale sign that no one cared for the health of the project long term. Imagine I sold you a new car, and it runs totally fine, but it's impossible to repair. As long as you drive it gently, never get a flat tire, never forget an oil change, never get in an accident, it'll drive perfectly. However, if any unforeseen damage affects the car, consider it totaled. If you design your software in a way that's not conducive to repairs or additions, you're setting yourself up for selling your users or clients that car. Every poor design decision that your developers made, either out of incompetence or a rush to a deadline, affects every sequential change for the lifetime of that project. You can end up compounding poor design decisions until the simplest of bug fixes or feature additions can take weeks, and your project becomes that new car, perfectly fine externally, but internally a mess. Just to give an example of a common bad practice that every developer has seen, imagine copying and pasting the same function in multiple different parts of an application instead of creating that one function in one place that every part of the application can use. Over time, each of those copy and pasted functions might have more changes made to them separately. Each of those functions can start growing apart from each other while still doing very similar things. In the future, if a developer needs to fix a bug that affects that function, now they're not just fixing one function in one place, they're fixing a bunch of different functions in a bunch of different places. This can be made worse if other functionality is created around this bad initial design, because bad design facilitates more bad design. The scary part is the impact of the compounding effects of these poor design choices tends to grow exponentially. This means that for the first 3 months of your project, you may be speeding along with no issue, but all of a sudden in the 4th month, progress slows to a halt. A poorly designed software project can be a bit like smoke and mirrors. From an outside perspective, everything seems to function well, but if you pull back the curtain, you can see the whole project is only a few feature additions away from completely falling apart. These are worst case scenarios, assuming that developers are not worried about the implication of any of their design decisions on the health of the project. This is exactly why developers can sometimes be over-concerned with project health, because they're painfully aware of how bad design decisions can leave the project foundationally damaged if left to fester and pave the way for less than ideal design choices down the line. A bad design decision could be looked at as a contagious virus in an application. When the poor design was implemented, it may have only affected some small part of the application, but if other parts of the application need to rely on that piece of code, they end up baking that bad design decision into themselves as well. A good developer might see this problematic code and attempt to isolate and abstract it, making sure it doesn't infect future feature additions, almost like quarantining a person infected with a virus so they don't spread it to their neighbors. Software is called software precisely because of its inherent flexibility. Modifications to hardware require actual physical changes, whereas code can be downloaded to your machine in 1 second, then changed and re-downloaded the next. What good quality code wins you is the flexibility that software promises. Designs and specs are often rewritten, APIs are often ejected from, and new APIs are often integrated. The world of software projects is a fast-moving, volatile landscape. A large aspect of your project is its adaptability in the face of that volatility, not just the question of, does this code work? The one tool that development teams have to create successful software projects that cannot be overstated is creativity. The main reason why developer satisfaction is so important and clean, high-quality code is a flagship of long-lasting, resilient software products is that clean code allows developers to exercise creative solutions. You can spend all day tirelessly fishing with a rod and catch a decent amount of fish, but if you decide to dedicate that time to inventing a large net, the number of fish you could catch in the long run would far exceed the quantity of the man without a net. That type of creativity, the power of those innovative solutions, are what takes your software and company to the next level. You don't want to be the company that's scrounging along trying to get by with fishing rods. You want to be the company that facilitates the invention of that net. Finally, I want to end this video talking about refactors. The cost associated with poor design decisions or badly written code is referred to as technical debt or tech debt. Just like when you're in debt to someone, eventually you have to pay. In tech, if you made a poor design choice in order to make a deadline, you've accumulated debt that you'll have to pay in the future. But in the case of software, you don't pay in money. You pay in development and planning time. And each feature you have to add before you can pay back that debt is like interest. Because if you pay the debt by fixing the original design flaw, every feature that used that original design now needs to be adjusted as well. This process is what constitutes a refactor. A refactor is a process of restructuring existing code without affecting its external behavior, generally. This means if a refactor is done correctly, the only thing really changing is the code. Now that you have an understanding of the intuition behind why good code matters, you should more clearly see the value of changing code, even if that code works as expected. However, we're talking about real production software with real users and real deadlines, so we have to exercise reason when deciding if a refactor is necessary. A lot of developers see refactors as all good, but this goes back to the misalignment of priorities I spoke about at the start of this video. Developers may tend to over-prioritize refactors, so let's look at the potential reasons that refactoring can be dangerous. The first reason is that you could break old functionality. Refactors have a sizable tendency to break existing functionality. In an ideal world, you could have test coverage prove the safety of a refactor, but most of the time your test cases are either non-existent or not sufficient to prove a refactor didn't damage existing functionality. For this reason, skepticism around refactors is warranted, and it's a good reason to code it right the first time. It will be down to your team and you to decide if the pros outweigh the cons here, and I hope this video successfully arms you for that conversation. You could ask questions about the scope of the problematic code, as in how many new features it could be affecting. You could ask where there could be potential risks in breaking critical existing functionality, or if the problematic code could potentially be isolated as opposed to completely rewritten. The second reason refactoring can be dangerous is the overzealousness of developers. The harsh reality is most companies do not have robust testing. In more than 5 years of coding, I have never worked on a project that had the amount of coverage needed to support even the average size refactor with relative safety. So when a developer tells you they're going to refactor fundamental parts of the application, alarms should be going off in your head. There's a pitfall that both junior and senior devs fall into. The danger is over-engineering. Sometimes people have really bold ideas with very wide implications, and their naivete gets the better of them. This comes back to the misalignment between developers and the business at large. If you have an actual profitable software product, you should not make it into the toy of your development team. Developers can have a really bad habit of having tunnel vision on non-mission critical pieces of the software product. I fell into this trap as a younger developer, and my advice to my past managers would be to silently acknowledge this misalignment of priorities, encourage the spirit of caring about the codebase, but redirect that spirit in a direction that makes more sense for the business's priorities. A development team that's over-focused on good code practice may be implementing rigid academic ideologies into your codebase that may lock you into problematic design philosophy down the line. Ideally, you should trust the developers you hire, but if something isn't making sense to you, I would suggest asking for some kind of architectural proposal and running it by another set of technical eyes. If you'd like those eyes to be mine, send me an email using the email in the description of this video for private consulting. I hope you've enjoyed this video. Please like and subscribe for more content demystifying tech. And this is Nick with NRC signing out. Thanks for watching.